All right, on the shark bite, which questions do we want to see you go over, have questions about? So majority twos and threes with some ones, so we'll do 1, 2, and 3. And then from those can all be done on Desmos. Or number one, if we have to find the slope through these points, if I type in these two order pairs. I think I forgot to open up the cart, so that you guys can use Desmos, but. And then from here, I could count the slope. I never really get a chance to use this, so. Let's see, we'd be going, if I'm starting from here, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and over 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13, 14, 15. We're gonna say up 10 over 15. Oh, that work. Okay. So that slope would be a negative 2/3. Make sure it says equals m. For this one, because of the distance, you would have to be zoomed out enough to count each one, or you could change the graph. I'll be right on a second. Change this so that the step is 1, so that the numbers stay there each time. On this board, my handwriting was even worse, so I apologize if it's hard to read. If you need to see what it says or clarify, just ask. For number 2, we have something we have to find the line of best fit. So in Desmos, we can put in all the points. Oh, I missed something. Okay. So then if I was looking at these points, to find the line of best fit, I can type in my y equals mx plus b, similar, but I'm going to use, this table has x1, y1, so I'll be using that. So y1, the squiggly line, the tilde, mx1 plus b. And that would give me my line of best fit. We'll use, it didn't actually say to write it, we just need to find the answer. So using that line of best fit, we need to find the closest length of time for a 6-year-old. So the age is 6, so that's going to be my x equals. And I'm going to find where those two lines cross. And that would be my answer. 199.51. The closest one to that is 200. So B was your answer there. And then for number 3, we could do that on Desmos, but also because it's given in y equals mx plus b, your y-intercept is at -1. If you wrote that as an ordered pair, 0, -1. So either b equals -1 or 0, -1. Questions on any of those 3? Let's talk about the SOL. So I'm going to show you all the answers for 6A and 6B, and then do this. You don't have to write down all the work, but write down at least the answers, either on your packet or on a separate sheet of paper. So all of this could have been done in Desmos. 6A was talking about slope. So number 1, to find the slope of these 3, part A was -3/2. Part B was 4/3. Part C was 2. For number 2, the slope was 1/2. Number 3, the slope was 1. Number 4, the slope was -2. And then go on to the next page. For number 5, the slope was -4. Number 6, the slope was -3/5. Number 7 and 8, you just had to plot 2 points that would fall on this line. So you could have put those in Desmos and just plotted points from it, or solved it and did that. The 2 points I have for number 7 are 0, 2, and 3, -2. And then for number 8, 0, 5, and 2, 2. And then for 9 through 15, you had to write the equation, but a lot of this you could do in Desmos. The equation would be y equals -2x plus 6 for number 9. For number 10, y equals 4/5 x minus 3. Number 11, y equals -3/5 x plus 3. And then in number 12, it asked for a line that'd be parallel, but you ended up getting the exact same line, so they actually wouldn't be parallel. But y equals 2x plus 4 was that answer. Write those and we go to the next page. And then 13, y equals negative 1/4 x plus 9. 14, y equals 3x minus 17. And 15, y equals 1/5 x minus 4. I'm going to show you a couple of these in decimals in just a second. The section that I do next, part of this is formative. Some of it we haven't done before, so I want you to do for next week, that's due on Monday, all of A6C through A7D. But the ones that are formative are these three sections: A6C, A7C, and A7D. So do all of those, A6C through A7D, but just the 2 C's and the 1 D sections are the ones that I'm going to check for formative grades. Really quickly, some of your decimals problems, anything that asks for the slope of a line and it gave you a line, type that in, count your slope. If it gave you points, put those in, count your slope. The ones that ask you to plot points, graph it, click on the line and find 2 points that you could graph or count another set of points. I don't have 9 here. For 9 through 15, you can use the slider method. Type in your y equals mx plus b. Add in sliders. Some of them gave you your y-intercept, so you could change that value. And then just change your m to go through the points, or vice versa. The perpendicular and parallel ones, change your slope to be whatever the slope is supposed to be, and then make it go through the y-intercept. Okay. Questions on SOL practice before we get into our notes for today? I may be in your way as I'm on the board, writing on the board, so if you can't see, just let me know. Or if you need to angle yourself more. So we started factoring before spring break. We talked about how to factor with greatest common factor, looking for what we could divide out of everything. We also found how we can factor by difference of squares when we have a set of perfect squares. So those were more for GCF, could be done on any set of number of terms: polynomial, trinomial, binomial. Difference of squares only works on binomials. And now we're going to talk about how to factor trinomial with 3 terms. So with this, I'm going to talk through the rule first, and then we're going to practice some of these. So when you have a trinomial where we're in this trinomial, there's an invisible a value in front of x squared. If your value is a, then this method works. we're going to look for two numbers that multiply to be C that adds to be B. So like for number 1, we need two numbers that multiply to be 12. Think of numbers that multiply to be 12. 4 times 3. What else?
6 times.
Times 2. Anything else?
6 times 2.
Okay. The negatives and the both being negatives would also work. What other numbers?
6 and 1.
Not 6 and 1, but
12.
12 and 1. And if you aren't sure what the factors are, you could start dividing, take the number, start dividing by 1, by 2, by 3, keep going. That's probably better for the bigger numbers. And then of these, which of these, if we added them together, would add to be 7? 4 and 3. So those are going to be the two numbers we use. So when you find your two numbers, you're going to have two sets of parentheses, two sets of factors. Whatever the variable is, you're going to put just one of them first in both. And then you're going to put those two numbers if they're both positive. So +4, +3, it doesn't matter which one you put it in. Questions on that so far? Okay, let's do number 2. Oh, that's a plus. So we're looking for two numbers that multiply to be 12 but add to be 7. All right, number 2, two numbers that multiply to be 20. What are some factors of 20? 2 and 10.
4.
4 and 5. 1 and 20. Now, sometimes you'll look at a problem and be able to figure out the two numbers right off the bat. If you want to list them all out, just so you have them for later purposes, you could also do that. So of these pairs, which ones could we add together to get 9? 4 and 5. So then our two factors would be n plus 4 and n plus 5. We do one more of these type and then move on to another one. Number 5. Two numbers that multiply to be 5. 1 and 5, it's primed. So that's it. When these two numbers are close together, like by 1, usually one of the factors is going to be 1. So then how would I write those two factors? Okay, +1 and okay, +5. Before we move on to another type, look at numbers 3, 4, 6. Just those 3 for right now. Are there any of those we want to see go over, have questions on before we go on to 7? In number 7, we now are dealing with the negative. So same as before, think about factors of 18. We'll just think about a positive 18 first. So what would give us a positive 18? 6 times 3. What else? 2 and 9. 1 and 18. Okay. That's it. And then because it's negative, we have to make one of the numbers negative. It has to still remain in the pair, but when we add or subtract it, it has to equal positive 3. Which pair could we use? Okay, Okay, and then which one could we make negative? 3. So then our two factors would be n plus 6 and n minus 3. So if you like to think about these as general rules, when you see two addition signs, plus plus, your two factors will have two addition signs. When you see a negative at the end by the constant, one of your factors will have a negative. It'll usually be the smaller number. Let's do number 10, and then we'll jump into some other ones unless you want to see some of those. The factors of 54. If you're not sure, start dividing in your calculator by 1, by 2, by 3, keep going. What are some factors of 54? 27 times 2. 6 and 8. 6 and not 8, but 9. 1 and 54.
3 and 18.
3 and 18. I don't think 4 works, but check it just in case. Did 4 work? Okay. And then you're done if you get something where the numbers are close. 7 wouldn't work, 8 wouldn't work, and then we already have 9. So then of those, which pair would work and which one would be the negative? 6 and 9, which number would be negative? Is 6. So then our two factors would be s minus 6 and s plus 9. Look at numbers 8, 9, 11, 12, 8, 9, 11 through 14. Any of those we want to see, do, go over, have questions about? Okay, moving on to 15. So now we have a negative, we have two negatives. So let's think about factors of 63. One and 63.
3 and 21.
3 and 21. 7 and 9. And I believe that's it. And then of those, which ones could we add or subtract to get negative 2? 7 and 9. Which one would be the negative? B plus 7 and B minus 9. So again, if you like rules, if you see two minuses, one of them will be a negative, one of your factors will be a negative. The bigger number is usually that one. Let's do 18 just because 72 has a lot of factors. What are some factors of 72? I'll write that on this. Extend this. 8 and 9.
4 and 18.
4 and 18. 7 and 2. You're close. double check in your calculator. $36. Anything else? I'm missing quite a few. I know we have the actual ones, but let's just list all of them. 3 and 24. Does 4 work? Oh, we already have that. Does 6 work?
12.
6 and 12. 5 wouldn't work. 6 and then 7 wouldn't work. And then of course 1 and 72. So of those, which ones could we add together to get negative 14? 4 and 18. Which one would be the negative? X minus 18, x plus 4. Do you have any questions so far on how factoring trinomials when a equals 1 works? Yes.
To be
When you say in order, like, do I have to put the 4 first?
Yeah.
No. It doesn't matter which one you do first. You just can't switch the signs. You can't put -4 and +18 because that wouldn't work. Okay, on the back of this, there's one more type of this that I'm going to show you. Starting with 7. So let's find factors of 8. Four and 2. And 1 and 8. Now I have to add or subtract these together to get a -6. How can I do that? Make them both negative. Because 2 negatives multiplied would get a positive, 2 negatives subtracted would keep this negative. So it'd be y -4 and y -2. So anytime you see a negative plus, both of them are going to be negative. Some of the other ones that are like this, 8, 10, 12, 18, any of those we want to see, do go over, have questions about. Sure. Okay, 18 looks more complex because it has 2 different variables, but it's really the same. So 2 factors, that multiply would be 7. 1 and 7 is 5. And these are 1 away. To make it -8, these would both have to be negative. And because you have 2 variables, you just have to have them both in there. So you're going to do m minus 1n and m minus 7. You just kind of split up the n's as you did the m's and put the numbers with them. Yes. Questions on 18 or other questions, 8, 10, 12. So we want to see you go over.
17.
17 is not like those, but we can still do that one. Okay. So find factors of 51. That's at least 2. 17. And 151. Which of those could be add or subtract to get negative 14?
3 and 17.
Which one would be the negative? So then our two factors would be x minus, I'm sorry, plus 3y and x minus 17y. Then if we were to distribute that back out, we could see that we get the same. Okay. There's one last type on this before we move on to the next set of notes. So we'll do a few of these and then take a small slight break. Sometimes you'll see trinomials where the a value is not 1. Sometimes what we're about to do works, and sometimes what we're going to do next class will work. We may have a GCF and have to do what we were just doing. Normally, if there is a GCF, it's going to be whatever that first number is. Sometimes that's not the case. So could I divide each of these by 2? Yes. So then 2 is our GCF. We're going to divide each number by 2. What would be left? If I were to divide this one by 2, what would be left? Yes. And then we are back to the trinomials where a equals 1. So then we're looking for 2 numbers that multiply to be 45, that add to be 4, add or subtract to be 4. What are some factors of 45? 5 times 9. And there are others, but I'm just going to stop right there because 5 and 9 would work. One of them would have to be negative. Which one would do that? Which one could be negative and then we add or subtract and get negative 4?
Negative 9.
Yes. So we would bring down that GCF on the outside, and then our two factors, we have k plus 5 and k minus 9. Any questions there? Let's look at number 20. If this one has a GCF, what would those have in common? May not be a number. the variable x. They each have at least one x in common. So if I were to divide each one by x, what's left? Plus. So x squared plus, not x squared again, 2x minus. And then we find two factors of 48 that would add or subtract b2.
Four.
Well, what else?
2 and 4.
2 and 24. What else? 6 and 8. That was supposed to be a 6. Not just me. 3 and 16 also works. But 6 and 8 would be our two factors. Which of those would be the negative? We have x on the outside, x minus 6, and then x plus 6. Are there any others of those we want to see, do, go over, have questions about? Take a small second to stretch, walk around, shake out sleepiness before we move on to the next thing. Pulls together, and this will be the last thing we do today. So the last, there's one more type of factoring we have to talk about, which we'll be doing Thursday. But this is another additional one. There we go. Words. This only works if you have 4 terms. So GCF works for any amount. Difference of squares is binomial. Trinomials when a equals 1. We just did that. And then grouping is your polynomials, your 4 terms. So we're going to do this example, and then we'll do some others. So first, you're going to group these together. You can either group them in parentheses. You could just split it down the middle. However you choose to do that, that's up to you. But when you group them together, you have to make sure this sign in front of the third term stays with that third term. Then we're going to look for the GCF of both groups. So what would these first two have in common? X. So I could divide both of these by not just one x, but x squared. So I'm going to put that out front and divide both of those. What would be left? X plus 7. And then what could we divide out of these last two? Positive 2. Okay. And then whatever this sign is, you're going to bring that down. So if we divide them both by 2, what's left? And before we continue, what do you notice about those? What? Everything in the parentheses is the same, which is what you want. That's your goal. If everything in the inside parentheses is the same, you know you did that right. If not, something is wrong. So then you're going to take everything on the outside. You're going to put those together in a factor in a set of parentheses. Then you're going to take everything that was already inside the parentheses. There are 2 of them. It's really a duplicate, so you don't have to write them twice. And you're just going to write that factor. And then once you have both factors, that's your answer. To check yourself, you could do this next step, but that one's not a requirement. If I wanted to check myself, I could distribute this back out. X squared times x is what? That's why these two x squared and x, what would that give us? X cubed. X squared times 7 is 7x squared. 2 times x is positive 2x. And 2 times 7 is 14. And that looks like the original. So if you get the original at the end, you know you did that right. But again, that is just a check yourself step. You don't have to do that step. Questions on how we factor by copayments? Yes. So now we're going to do some of the examples. So starting with example 1, split that down the middle. What do those first two have in common? Daniel, make sure you're writing this down. What could we divide out of these two? Okay, the variable, how many x's? 3x squared. If I'm not going to have space to write that I'm dividing each piece, you could do that if you want. You don't have to show that part. If I'm dividing 3x squared to both of those, what's left? And then what could we divide out of those last two? What do they have in common? -2. So bring down whatever that sign is, and I can divide both by a 2. The -2, so your signs are going to change. When we divide those both, what's left? -2x divided by 2 and -10 divided by 2. Not 20, you're dividing. So you can almost assume what that inside is going to be, but also don't at the same time actually divide it out. And then our final two factors, the outside pieces, 3x squared and -2, put that in parentheses. And then just bring down one of the inside. Questions there? I'll let you guys choose some of the others. Look at the others on this page. Which ones do you want to see? Do you go over, have questions about? They're all confused. Now would be a great time to ask. Number 3. So in number 3, go ahead and split that down the middle. What's our next step? What do we do after we split it down the middle? Split it down the middle. What's next? Okay. They both have x squared in common, so if we divide out x squared, what's left? And then do the same thing for the second two. What will we divide out? -5. And then what would be left? And then how would we write our factors? If you got something like this, you were factoring, but let's say instead of x squared minus 5, you got this. So this is a fake answer. I'm making this up. Let's say you got this instead. This is not a difference of squares because 5 is not a perfect square, but 4 is, and we talked about how to factor that. This would have to get broken down more. You would have to factor this, otherwise this would not be counted as correct. So this, we could go back and do our difference of squares. What times what will give us x squared x? What times what will give us 4? 2, and we put a plus and a minus, and then we would still bring that other one down. So in a case like this, you would have 3 factors instead of just 2. But you have to be on the lookout for that. If you get something like 4, 16, 9, 25, 51. Right? Any others on that first page that we want to see, do go over, have questions about. Right, with 6, split it down the middle. Divide. What do the first two have in common? X squared. What would be left? Y plus 3. What could we divide out of the last two? Positive 7 and negative 7. And what else? Not just negative 7, but negative 7y. And if we divide that out of both, what's left? Y plus 3. Then what would your final two factors be? I'm going to show you one more example where you might have a GCF with grouping. And I'm just going to use the same one we just did, but do this off to the side. Or if you need more space, grab another sheet of paper or do this on the back. So I'm going to write this as, just rewrite this next to it, or excuse me, wherever you have space. The 2x squared y plus 6x squared minus 14y squared minus 42y. Write that somewhere where you have space. And then we're going to do that just like normal. split it down the middle, find the GCF of both sides. So what could I divide from these first two? 2x squared. What would be left? And then what could we divide out of those last two? Negative 14y. Leaving y plus 3. So then we'd have our two factors, 2x squared. That is a 2. It doesn't look like it. Minus 14y and y plus 3. But in these two factors, one of them is not prime. What could I divide out of these two? 2. Which means I had a GCF at the beginning that I could have factored out then, but it's okay as long as I factor it out eventually. Okay. It was right, and then it wasn't. Erase all of that. So if I had seen that I could divide something out of the beginning, I could have did that and then just kept bringing down the GCF. Or if you see it at the end, divide it out. But you can't leave this factor like this. It would not be factored completely. Okay. So then for the remainder of class, you could be working on one of the following. More problems from the notes, your Delta math for this that is due Friday, your JLab, your SOL practice that's due next week. You guys have a bunch of different things you could be working on. Work on something. So if you are missing the Delta math from the before spring break, now would also be a good time to do that.